Once again, we are given a graph of a function, and we have a different function that's defined in terms of the area under that graph. So the area, or the graph we have is of R. The function we're dealing with deals with the area under the R curve. The dollops per gigaflick label is just some nonsense label. A dollop is just, of course, an arbitrary unit of volume, like put a dollop of whipped cream on that pie. A gigaflick is a legit label. If you have done any video editing, you probably maybe have heard of it. It's a pretty new thing. It's kind of interesting. Google it sometime. Yeah, you got the day off. Anyway, in this case, we have to figure out at what time from 0 to 10 does G reach its max. And this is something you can do kind of with a little bit of just kind of common sense, I guess. Since G is defined as the area under the R curve, you are trying to figure out at what point on this interval you have accumulated the most area under the R curve. So as we go from starting at 0, the graph is above the x-axis. So as we begin, we are accumulating area. And right here, we are at least a relative maximum. Now, beyond that, what happens is you start losing area. So as we accumulate area under the x-axis, you're taking away from what you've already had. And yes, at the very end, you do gain a little bit more of that area back, but this little bit that you've gained back is not enough to make up for all the area you've lost here. And then, as a result, what that tells me is right here is where we have accumulated the most area under the curve, and therefore that's where this G value, which is the area under the curve, is at its absolute max. So we can say x equals 4. If we have to justify it, we could say because the area under R has increased the most on the given interval. Now to follow up, they say what is the maximum value at that time? So there you actually have to find out what the area is. Well, in order to do that, you have to, again, go back to our old pal, box counting. Here we've got a triangle. Well, let's just do this. We've got this triangle has an area of 2 by 4 over 2. So that would be an area of 4. Then we have this rectangle that has another area of 4. And then we have this triangle that is 1 by 4 over 2 would be 2. So we've accumulated 4, 8, 10. We could say G of 4 is 10. For part 2, this time the function is a different function, h of t, and that's defined going from 0 to g of t. So we have a function as our upper limit. But the good news is we still have a constant as our lower limit. So if we have to differentiate h, we can still use second fundamental theorem. It's a little bit weird looking, but it still works. It still applies. Trust the system. To get the derivative of h, we are going to remove the integral and keep this function, r of something, but now we're going to plug in the upper limit for x. So h of t in general is going to be not r of x anymore, but r of g of t. And we have to chain on the derivative of that upper limit. That's going to give us g prime of t, chained on. That's just your generic formula for h prime. Specifically, when h prime or when x when t is 3, we simply take out the t's and put in 3's. So now we're going to have r of g of 3 times g prime of 3. And we can use the graph to get the first part, or eventually. By the way, g of 3, yeah, this is tricky. Okay, to get g of 3, we got to go back to what g of t is. G of 3 will be the area under the R curve from 0 to 3. The area under the curve from 0 to 3 is all this area, which is 4 plus 4. So G of 3 is 8. G prime of 3, how do we get that? We need G prime. Gosh, we need a function for G prime. That's just going to be R with T plugged in. We're chaining on a 1 here. So G prime of 3 is simply R of 3. R of 3 we can get right off the graph. That's the height of the R graph, which is 4. So now we just figure out R of 8, which is apparently -1, times the 4 we already got is going to give us -4. Sneaky problem. There's a lot going on, but if you can work your way through this, you can work your way through anything you're going to see on the assignment.